Hello grade 12s, welcome to my channel, and we have worked through simplification of trigonometric expressions where we are given the actual angles using our reduction formulae and cofunctions, and coupling that with identities and special angles, sometimes needing to factorize here and there, and sometimes just purely simplifying using bottomers, and perhaps at times using a particular law or something. So we have done a whole lot of work yesterday. We did the question 5 essentially. So now what we need to do, I don't know what happened. Okay, yeah, there it is. Oh yeah, it's all of these other questions. So we've also done proving identities. So we kind of worked through, of course, I just made a video of question 3 and 4. And unfortunately, guys, we were supposed to cover this question tonight. And due to some issues, I could not actually do the lesson. And the worst part, I even wasn't able to let you guys know beforehand. So I'm just going to do this video. You guys must just watch it. And then tomorrow evening, we meet again and try to take some more examples of the 3D structure, because these are easy marks that no one should miss. Okay, and who knows, maybe over the weekend, if you guys oblige, we can maybe look at some trigonometric functions so that we know we have covered most of the topics that are going to be part of term 1, because next week I want us to tackle functions properly, and then we can do some proper revision, hopefully before you all write your exams. And yeah, good luck with everything. Those who are upgraders, I will keep on just dropping some random content that is already ahead and perhaps slightly advanced for the matrix of 2025, because in their term 1 exams they will probably not have to face as much questions as you guys I'm going to show you, because the matron exams are just around the corner, so we've got to make sure we make it count. Anyway, so here we're going to read the information given, because that's the strategy. Questions like this, the 3D structure, we first read properly what's given, but any other question, guys, should be approached the doctor style, isn't it? The captain of a boat at sea at point A, okay, there's point A, notices a lighthouse directly north of his position. So that's H, right? He determines that the angle of elevation of L, the top of the lighthouse from A, is theta. You can see it, okay? And the height of the lighthouse is X meters. Okay, that's also given. From point A, the captain sails 12x meters in a direction beta degrees east of north to point B. See, beta degrees east of north, right, to point B. So this is also given, and that is also given. Now, we are also told that from point B, he notices that the angle of elevation of L is also theta. So these are essentially equal. These are equal angles. Okay. All right, okay. So what can we say about these two triangles, guys? This triangle right here and that triangle right there. These become congruent triangles. How do we know? We know that essentially this angle is equal to that angle, right? Right. That's number 1. Number 2, we've got this common side, right? Right. and we've got that angle and that angle as well. So obviously guys, obvious is obvious. Hey, but I don't think it's a strong reason, is it? Not yet quite a strong reason for congruency. Okay, maybe let's ditch it for a moment, because it could be the right angle and hypotenuse side, but now we're not sure that we have the same thing. We cannot be too sure. Yes, we've got a common side, we've got the angle, we've got the other angle. So is it angle side? I don't remember such a thing, is it? Hey, let's just ditch it for now. Let's just ditch it for now. I'm not too sure if I'm lying or I'm telling the truth, but sometimes think about it so that as you progress, you just keep it close. Now we're told A, H, and B lie in the same horizontal plane. That's good. Usually it gets shaded, so this is the same horizontal plane right here. Okay. We need to determine AH in terms of x and theta. So this is the question here, AH. So obviously guys, we've got a side, we've got at least two angles. So we know that we could easily determine that angle. It's going to be 90 degrees minus theta from three angles of a triangle. And essentially, we can use the trig ratios here to find AH. Whether we use this angle or we just use what is given. And I think what is given is good enough, because theta is opposite x and this is adjacent to theta. So we can just use tan theta. So 6.1, we're going to say tan theta. Oh, sorry. Where are we? In triangle AHL. Sometimes the naming is not really that much of a big deal. As long as we can identify this, we know that the tangent of theta is essentially going to be the opposite side. Now remember, we don't necessarily need to write the original definition. We just write exactly as it is. It's going to be x over AH. Okay, this one we don't justify, so this is essentially over 1, so we just cross multiply and solve. What are we looking for? AH. So this therefore tells us that AH, after all the manipulations, is going to be essentially x over the tangent of theta. And that's it, guys. There's nothing here to spend too much time on. So we get a mark for just the definition and the answer as is required. So 6.2 says we need to prove that the tan of theta is equal to cos of theta divided by 6. So obviously, once we start to see, this is the same as those Euclidean geometry issues. You look, where is this angle? Cos beta is there. Where is 6? Well, 6 is a mystery, but it means it's just part of the simplification. So where are we exactly? We are then pushed into this triangle. And we can see that this is the common side. AH is common here. So what are we going to do? If we got a cos of beta, when do we ever use a cos of beta? When we have the cosine rule. Now, what does the cosine rule suggest? It means we also need to find that side, HB or BH, because we now know we can actually use the cosine rule as soon as we know all the three sides and an angle at least, because then it's going to be a game of just playing with the tricks. So technically, we need to get into this triangle on our own, then move into this triangle on our own, and we get our answer. So these two-step or multi-step type of questions, it's more like proving identities essentially. because this is how these identities are actually constructed. It's just that you wouldn't know. Anyway, let's get to the business of the day. So we always look and see, can we get clues from the question itself? Can the expression given to us give us some clues? And we take it from there. So we'll start in saying, in triangle. Now remember, I'm looking at this triangle. So I'm going to use it as my reference triangle as part of my solution. So I'm going to say in triangle A, HB or ABH, whatever. I'm looking for HB, right? Right. So I'm going to say tan. Again, I'm going to use the tangent because I've got the angle theta in this other triangle, but I'm going to use it as a means to an end. So I will say tan of theta is equal to, the opposite is going to be x over, this time I'm going to say HB. That is using, you can just say C triangle LHB. Okay, so I'm just trying to show that I'm going to find HB using the other triangle for this triangle. Okay, so what do I want? Again, this is all over 1. Then we just cross multiply. And so we know that HB was our target, is certainly x over the tangent of theta. Now we can clearly see that this one is equal to that one. Now we can make an argument for our congruency. We couldn't really say it. I don't know if I was missing something, but now that we know, we can essentially say, well, there's a side, an included angle, 90 degrees, same story. Therefore, those two triangles are essentially congruent. And if they are congruent, it also means that this side is also equal to that side. So that's just the essence of knowing how to get around business. So we can say then, we know that we just needed an extra side. We know that remember, what is our reference triangle? Is AHB. We just needed that side using the other triangle. So what we can say now is, we understand that essentially the opposite side to the angle, which is going to be HB squared, is going to be equal to AH squared plus BH squared. Okay, we said HB, maybe let's do that. Let's just keep consistent with how we named it so that we don't end up confusing our markers. So we've got AH and BH, the cos of an included angle, which is angle beta. Here there's no point in, honestly. Okay, maybe we want to do substitutions properly, so we can say cos of HAB, and we know this is the cosine rule. Okay, now what do we know? We found HB to be x over tan theta equals AH, we saw it as x over tan theta, plus BH, did I say BH? Man, it's supposed to be AB. Ish. See this guy? This is supposed to be AB. These sides must include that angle. Okay, we can say this one is AB. Sorry guys, please pay attention. If this is forgotten, just check the information sheet. So AB is given as 12x. By the way, we square these things. I don't know why I'm failing to do so. We should be squaring them. Minus 2 into x over the tangent of theta into 12x. You can say over 1 here because there's a product, times cos of beta. Nice and easy. So all we do, we just simplify, guys. So we know that exponents, when we've got fractions, it distributes to the numerator and denominator. So we've got x squared over 10 squared theta equals, again, x squared over 10 squared theta into 144x, sorry, not into but plus, yes, Lord. Be very careful when expressions are too busy. This essentially multiplies into the numerator, so it's going to be 2 times 12, which is just 24 x squared all over 10 theta times cos beta. And we can see our job here is to just try to keep 10 theta somehow on the left hand side and keep cos beta on the right hand side, but it's all going to be just manipulations. And remember, once we've set something up, can you see 3-step approach still applies here, because we used a rule that's a cosine rule or some law. You can even call it a law or a formula. And guess what? We just substituted however we got to this triangle, and then after substitutions we just need to simplify a trig expression like we do any algebraic expression. So let's see, what are we doing now? This is a like term to that, so we can collect like terms, right? Yes. So we will have here, this implies that in fact we don't even need to think about it. These are the same sign on either side of the equation, so they will essentially just cancel out as soon as we transpose one side to the next. So this makes our lives a lot easier, because you see now we only get 110 theta, nice and easy. So it makes our lives a lot easier. But then we just want to, I'm trying to think, okay, so this is going to be 0 is equal to 144x squared minus 24x squared all over the tangent of theta times cos beta. Now what are we trying to do? We want to get 10 theta out of here. So how are we going to get this out of here? We then transpose this whole term to the left hand side. So we will have 24x squared all over 10 theta times cos beta. Okay, maybe let's just move it a bit so that it doesn't, yeah, I can't. Let's leave it. It's not a big deal if we drift a bit. So this is going to be equal to 144x squared. You can already see what we need to do here. So what we need to do is to essentially, guys, do what you call gymnastics. We could easily have solved this fraction actually, but it's not a big deal. So this is over 1, so this is just going to force us to do a bit of a flip-flop in cross multiplication. I think it's better that way. We do it this way. So this is going to imply I'm going to keep whatever 10 theta multiplies this as. It's going to be 144x squared times 10 theta and equal to 24x squared cos beta. Okay, so obviously we need to divide by 144x. So we're going to have 144x squared there and 144x squared. And then 144 takes care of 144x squared. X squared takes care of x squared. So we end up with essentially 24 over 144. And guess what? Therefore, 10 theta is, we know 24 goes once, goes 6 times to 144. Let's just check on the calculator. So it's a very nice algebraic expression. See, 144 divided by 24, yeah, it's 6. So Now let me see, can I push this up so that I can be able to write my final answer nicely? Okay, so I just want to write my answer properly on just this page. So therefore, we appreciate that indeed tan theta is going to be just cos of beta divided by 6. As was proposed. So we got it, guys. Nice and easy for that final of 11 easy marks. Of course, these are very technical questions, multi-step essentially. So first of all, getting this HB, because it wasn't asked, we had to find it. Now, using our cosine rule, usually in trigonometry, when we use a particular rule, we get a mark. That's good because we are writing that rule in terms of this triangle. That was not given. We had to figure it out. Then we do correct substitutions as always. When we have a formula, we substitute, we get our marks. Then the actual simplification, guys, is not such a big deal, but sometimes we need to still gather our marks. All right, we still need to gather our marks. So essentially, we've got 3 marks here. And all the gymnastics, guys, here, because we haven't used any identities whatsoever. So I guess from this we can just say, using our BODMAS here, this is what gives us another mark, because we want to ensure that we get our marks. From here, it just simply says, guys, everything is just nothing but simplification. So do we really want to say too much about it? Well, it doesn't matter. The answer was already given, so we can mark this step, even though it's not quite a strong point. Sometimes, even though this was given, it could still be marked as long as it ties with our construct all the way to the end. So we take our 5 marks in there. Okay, so actually I rushed. This question is not done. We still have one more question. So we've got 6.3. We are now given that AH is 60 meters and beta is 40 degrees. We then need the height of the lighthouse. So this is not so difficult, because we saw something that if AH, remember we defined AH and the height is this. But now look at what we are being given. We're not given theta. So we are given beta, and if you look at it, it's 4 marks. It means we need to first find theta so that we can finally land ourselves into this equation right there, because this is the equation that's the easiest to define our tan theta, or essentially this equation we could still also use. So it doesn't really matter. So technically we need to find the value of theta. That's the plan. So we know that tan of theta is nothing but essentially cos beta over 6. That's what we got. So this implies that tan theta is going to be cos of 40 degrees over 6. Therefore, we know that theta is going to be the arctan of cos 40 degrees. Sometimes just write it out nicely like that. Don't waste your time with the decimals. At this point, it's just an acute angle. We can see that, or whatever angle it is. So we don't need to do general solutions here. So what is the value of theta here? So we're going to say shift tan cos of 40 divided by 6. Just be careful with brackets here. They can really cause trouble. So we find theta that it's 7,276 degrees to 3 decimal places, just to protect our answer. And now we can say then we understand that AH is being equal to x over the tangent of theta. we continue. AH is given as 60 equals x, which is the height of the lighthouse, which is what we want, and therefore we've got 10 of 7,276 degrees. So essentially we just cross multiply that to find x. This is going to be 60 times the tangent of 7,276 degrees. And we can say therefore the lighthouse, the height of the lighthouse LH is equal to let's see what is this, 60 into the tangent of 7,276. Be very careful with brackets here, they can cause trouble. So I'm getting 7,66 meters to 2 decimal places, because nobody told me otherwise, unless the instructions don't suggest as much. So guys, this is how you deal with these questions. As you can see, multi-step questions demand a bit more, but it's nothing but just the understanding that we already have. So let's get the marks here. First of all, we need to get this one. It's important. And we can say here correct substitutions, final answer with the correct unit of measurement. It has to be meters, otherwise chisampama. And what else, guys? Well, I don't know, guys. Sometimes maybe we can just say 2 marks or anywhere else, because I don't see any stronger point for the extra mark. And that's it, guys, for this question. We will do more tomorrow so that we can cement what we have been doing. And I believe you guys are doing great. Otherwise, leave a thumbs up and practice as many of these questions as you can. Here's the strategy here. The strategy for questions like these is to essentially, first of all, calculate all possible angles. Okay, very important, meaning you look at any given information, you calculate all the angles that are possible. I mean, like I've shown you here, same could be done here to show that these angles are equal. So this would be 90 degrees minus theta as well. So we do all of that. Just do it. And then the second step is to start from the triangle. Start from a triangle. Usually this is going to involve triangles. Or let's just say figure. Sometimes they can make it a square or a figure that has at least 2 angles and a side. Okay, at least 2 angles and a side. There has to be a side. And then what do we do here? We work towards a common side. Okay, and once we do that, we then essentially simplify our final expression, or let's just say simplify the final expression. And what is that? The 3-step approach. And don't forget, all of this thing builds from our doctor's approach, essentially, because we need to read the statements, understand them. If nothing is labeled on the sketch, we label it. If it is labeled, we identify it. And then we examine our sketch objectively. We put it to the test and we get our job done. All right, guys. So I hope this is great for you. And don't panic. these things are easy. You just need to be comfortable with simplification of trig expressions. That's just the tough part here. You need to know how to do the 3-step approach as I have highlighted it in our lessons, and you need to be comfortable essentially just going into the deep end. Sometimes certain questions are too demanding even for me, so there's no excuses, guys. We do our best and we ensure that we score as many marks as we can. So we'll discuss this further tomorrow, and maybe over the weekend we need to treat our trig functions. All right, anyway guys, goodbye. I'll see you again next time.